Hello and good evening. My name is ZSmidt, and my team, including myself, JKujawa, and DHosea, will speak about web application firewalls, or WAFs, describing what they are, what they do, how they are implemented, benefits and detractors, as well as examples of such a firewall in action. During this presentation, we will review what a web application firewall, or WAF, is, the different deployment options, including Layer 2 bridge, reverse proxy, server resident and internet hosted / cloud implementations, WAF positives and negatives, some well-known features of a WAF system such as protection, building policies, auditing and alerting, and virtual patching, and provide an example of risk mitigation in an enterprise environment. To start with, what is a web application firewall, or WAF? At its most basic, a WAF filters, monitors, and can block HTTP traffic to and from a web application. It does this for a number of reasons, such as to balance traffic, to monitor web conversations, and to identify and repel traffic that is deemed malicious, but its primary purpose is to protect web applications from bad actors, a critical function in today's business world. There are a number of different methods to deploy a WAF, but we'll be speaking with you today about some of the most common. These include a Layer 2 bridge deployment, where a WAF inserted at the data link layer examines packets, a reverse proxy deployment, where a WAF examines incoming packets and forwards acceptable packets to a web server, a server resident WAF deployment, where a software solution installed on a web server acts as a WAF, and an internet hosted / cloud deployment, where incoming packets are examined and managed by a cloud service provider to scan and filter packets. A Layer 2 bridge is among the most common types of web application firewalls, and it works by sitting in between the traffic load balancers and the web servers. It makes a copy of incoming packets and performs decryption of the copied packets to validate that each packet is reviewed based on policy and approved. Packets not approved or deemed malicious are discarded, while packets deemed acceptable are re-encrypted and sent on their way to the web server. A reverse proxy works a bit differently, as incoming packets are sent directly to the WAF, where it then decrypts each packet in much the same way as a Layer 2 bridge, analyzing the packets, validating and discarding packets where appropriate. A server resident WAF is quite a bit different than the previous two implementations, as it is a software solution installed on a web server rather than a physical device. Using either an application or a plugin installed on the web server, traffic that hits the web server is filtered and sorted based on company policies using the WAF. Based on these policies, traffic will be approved or discarded based upon the rules within the WAF. Out-of-band WAF implementations are somewhat less common, as in this implementation the WAF is not in line with the web traffic. It receives a copy of the traffic via a monitoring port on a networking device. It can passively decrypt SSL traffic so as to have the least amount of impact on the network and application latency, and this allows the WAF to be configured to only alert on malicious traffic that's detected, potentially reducing the danger of blocking false positives. This deployment mode is less commonly used, even though it provides the least impact on overall server performance. In the diagram below, we can see a WAF sitting off of a switch, receiving a copy of traffic which is then routed to the web server. The final WAF deployment option we'll be discussing is an internet / cloud deployment. This relatively newer type of implementation involves forwarding traffic to a cloud or hosted service where the service provider will scan and filter packets in a similar manner as a reverse proxy, discarding denied or malicious packets while forwarding approved packets to their intended destination. While newer than other types of implementations, this method of WAF implementation is growing at an extremely fast rate due to its relative ease of implementation compared to other options. Now to speak about the positive and negative WAF security models, I'll hand the presentation off to JKujawa.
Thanks, Zach. I'm JKujawa, and I'll be covering the security. There are two ways to generate the security. As you can see, a WAF protects against a very large number of One of the key features of a modern WAF is virtual patching. Auditing alerting is a key feature in maintaining.
Thanks, Jeff. This example will demonstrate through a series of screenshots of how WAF will detect cross-site scripting attack and protect the website before the site owner can implement source code update to address the cross-site scripting vulnerability. To begin, as shown on the below screenshots, we have a PHP-based web application called DVWA. For the sake of example, DVWA website has a page that uses a form asking for the user's name, which will then echoes back the person's name based on the input. In this example, we can see that the user typed the name Jason, and the result is a text echo of "Hello, Jason." Instead of typing a name, a user can type the following input as shown on the slide, which will create a pop-up box that says XSS. This is a shortened term of cross-site scripting. This definitely deviates from the website owner main intent of enter your name page. This vulnerability is called cross-site scripting. For this example, cross-site scripting is used to deface a website. The attacker in this example used injected scripts to change the content or output of the website. In its worst form, cross-site scripting can even redirect the browser to another web page, one that may contain malicious code. The reason why this is happening is because this website does not have input validation to restrict certain characters or patterns to prevent cross-site scripting, which is where the WAF can help. From the previous two slides, we have covered the original function of the DVWA enter name input page and how it can be vulnerable to cross-site scripting due to lack of input validation. To confirm that DVWA has cross-site scripting vulnerability, a Burp Suite web application vulnerability scanner tool scanned the website, and the result is shown on the screenshot to confirm that the website is indeed vulnerable to cross-site scripting. From the Burp Suite scan result, we are now starting the cross-site scripting mitigation process by using the WAF feature of virtual patching. In this example, ThreatFix is used as the WAF. As Jeff mentioned in prior slides, virtual patching is when you import a web application vulnerability scan result into the WAF, which then dynamically updates its attack signature database to protect against these newly identified vulnerabilities. This allows a site to be protected from a vulnerability before the site owner implements the code update to address the vulnerability, which in this example is cross-site scripting. The screenshot here is showing that the Burp Suite vulnerability scan result is being uploaded to the ThreatFix WAF. After uploading the Burp Suite's web application scan result into the ThreatFix WAF, it then dynamically updates its attack signature database as shown on the screenshot. On the next slide, we will run the same input on the website with the new WAF rules to demonstrate how WAF is effective in mitigating cross-site scripting vulnerability. As shown on this screenshot, the same input has been entered again on the website that has the cross-site scripting vulnerability with the addition of new rule in the WAF that was dynamically created from import of the Burp Suite web application vulnerability scan result. As you can see, the output forbids the user to further exploit the website cross-site scripting vulnerability. This forbidden output page was pre-configured in ThreatFix as an output to display to end user if any of the ThreatFix WAF rules were violated.
To introduce another example of risk mitigation, we'll be observing a DDoS to discuss what it is, the different attack vectors that might be used, and how a WAF could help mitigate or lessen the impacts of such an attack. Distributed denial of service, or DDoS attacks, are an attempt to disrupt normal traffic of a website or web server by overwhelming it. DDoS can overwhelm in a variety of ways, but they're almost like a traffic jam blocking a roadway, preventing traffic that you want from reaching its destination because it's being blocked by traffic that you don't want. DDoS attacks can come from a number of vectors, but most recent attacks typically fall into three distinct categories, each areas where a WAF can assist: application layer attacks, protocol attacks, and volumetric attacks. The first category of DDoS attacks, application layer attacks, work by overwhelming an HTTP server with requests. Since DDoS are performed using a large number of malicious clients or botnets, millions, billions, or in some cases trillions of requests could be created, sent, creating a massive wave of requests that a server cannot possibly handle. While for some sites 1 million people sending requests may be an everyday occurrence, imagine if 1 billion people suddenly visited your site and started all refreshing the page at the same time. This slowdown can easily bring down or slow down a site if not mitigated properly or prepared for. While particularly difficult due to the sheer number of requests, a properly set up WAF at the ingestion point along with a series of load balancers could potentially notify staff about the event and distribute the load fast enough so that the site isn't brought down if set up properly. In this example, we can see an attacker controlling a series of bots to send HTTP requests to a target server. A properly positioned WAF, as shown here, providing package filtering, could potentially allow a business to see spikes in traffic or potentially sniff out the beginnings of an attack as it's being started, a huge benefit of having a WAF in place. Very much like the application layer attack that we previously observed, a volumetric DDoS attack aims to create congestion through applying the volume of requests to a server that it simply cannot handle. Unlike an application layer attack, a volumetric attack uses DNS servers as a proxy to send spoofed requests to a target server, making fake requests that are sizably long requests, thus slowing down the server. Imagine if somebody ordered 100 pizzas and sent them all to your house when you didn't request any. Just like it would take you a long time to sort through all of these unplanned deliveries, a server would take a while to sift through millions of unplanned requests, slowing it down or in some cases crashing the server. In this example of a volumetric attack, we can see an attacker using a bot to send requests to a number of DNS resolvers who then act as proxies to send bad requests to a target server or site, triggering a slowdown because the server cannot respond to these requests in a timely manner. Protocol attacks work a bit differently than the previous examples that we've discussed, application layer or volumetric attacks, as these attacks work by specifically targeting the firewalls, load balancers, and state tables on a server to overload it. As this attack vector specifically targets firewalls and WAFs, if the business isn't adequately prepared for such an attack, it can be disastrous. To imagine such an attack, what if you went to a store, purchased an item, and they sent someone in the back warehouse to get the item and didn't return until the order was completed? While the worker is getting the package you requested, you continue to make more requests for more items, which are then relayed to the worker, delaying them to the point where they become overwhelmed and can no longer respond to your requests in a timely manner. This is a protocol DDoS attack. In this example, we can see an attacker sending faked packets to a destination server, but the server responds to these requests by sending an acknowledgement reply to a faked client address. This delay in waiting for a response to the sent acknowledgement packet ultimately delays the response for legitimate clients and slows down the server. With each of these examples provided, where does a WAF come in and why is it important? What we've learned through these examples is that online security in the digital era is multifaceted, and no one solution will prevent an attacker from attempting to bring down or attack a server. While a solution must contain many mitigation strategies, an important item in that strategy is a web application firewall, as it can be used in tandem with other security systems to detect, limit, or in some cases thwart a DDoS attack. Since DDoSes vary so widely in the attack vector, scope, and size, and with some of the recent attacks reaching trillions of requests to a target web server, destabilizing the internet itself, a WAF definitely isn't a foolproof option to prevent these attacks, but having a WAF in place is invaluable to improving the speed of reaction and making quick business policy rule adjustments to attempt to counter them in real time.
As we have shown through this presentation, a web application firewall can be a valuable and flexible addition to the security suite of any organization with web-based applications. The various hardware and software solutions that can be deployed both on-site and off-site provide the ability to tailor each security strategy to the individual business's needs and budgetary requirements. A WAF provides up-to-date and future-proof security through vendor support with regular updated attack signature databases, virtual patching that closes security holes before they're even known about to the vendor or to the business, and dynamic policy modifications that continue to tailor security to each site's needs. The WAF is a tool that can provide support and protection against a multitude of types of attacks to the web-enabled application. While there is no single security measure that will completely protect against every online threat that there is out there, a web application firewall does provide a robust library of support for the most common and damaging attacks that happen every day on the internet.
Thank you for listening to our CIS 665 Introduction to Web Application Firewall presentation. I hope you have gained insight on what a WAF is and how it can protect web applications from vulnerabilities. Once again, this is Team 109 with DHosea, ZSmidt, and JKujawa. Thank you.